If you are running an outboard with electronic ignition, which is virtually every outboard made since the 1980s, this video is for you. Unlike most parts of our sailboat, the CDI units show no signs of wear and tear before failing. Ours failed without any warning. In this video we're going to cover fault finding when you don't have a spark, 2 methods to try to fix a faulty CDI, and replacing the CDI. By way of background, we'd been motoring under 2 engines for about 20 minutes, and then suddenly one of them died. It's a Yamaha high thrust 9.9 horsepower, 6 years old, and seen only about 500 hours of use.
And now we'll give it a shot.
No spark can occur from at least 10 different causes, and you will need to run a series of tests to isolate the problem. The simplest test is to bypass the CDI unit. There is a label on the flywheel cover showing you how. We disconnected the yellow wires as suggested, but still did not get a spark. This indicates that the problem should not be with the CDI. The tools we used to run the rest of the tests are a digital multimeter, some pliers and suitable socket spanners or wrenches. We also outlaid $90 for the service manual, which we were able to download online. This has all the voltage and resistance readings for each of the parts we needed to test, and guided us through the diagnosis. The tests are neatly laid out in the manual, beginning with the simplest to check first: the fuse, power to the start button, continuity across the start switch, spark plugs. We replaced ours with new ones and still didn't have a spark. If you don't have new ones, there are simple tests you can perform to check your plugs, and I will put a link in the description to an excellent video showing how. Assuming the plugs are okay, you still need to check that the spark plug caps have resistance to within 4,000 to 6,000 ohms. Next is the ignition coil, then test continuity across the engine shut-off switch. We tried running the resistance and the voltage output tests in the shop manual on all the components, and only on the charging coil, the ignition coil and the spark plug caps were we able to get results that they suggested. These first 7 items all checked out okay. That left the pulsar coil and the CDI unit itself. But the pulsar coil and the CDI didn't produce the results that they suggested on either coil, on either CDI, and we knew that one of them worked. At least one of them worked. What we needed was a direct voltage adapter to measure peak voltage on these components. Dangar Stu shows how you can build one, and I will put a link in the description. So Zaya suggested that we start swapping the parts out between the engines until one of them doesn't work. And it's not a bad idea. Viewer Frank Krasik tells us that Zaya's method of problem solving is called swaptronics, and it underscores how catamarans do redundancy very well. We've put the unit that we think is faulty in the other engine in it, which used to run, and it didn't run with it. And this is the CDI out of the other engine that we're putting into the engine that didn't run. And if this works, then I think that's a categoric diagnosis that this is the CDI and the port engine is naff.
You find the fuel tank, the air vent and stuff.
Should I do it?
That's alright, I'm just going to fire it.
Ooh, works! Steady.
Not only did it start, but it just wanted to start.
Yeah. Ooh, yes. So that's the problem. CDI.
Yeah.
Now we had one working CDI and one faulty one. We returned to Georgetown a couple of weeks later, ordered a new CDI unit, and met with new guest Mick from Norway, who wanted to try and fix the faulty unit.
We have tried to order a part from the US. It will take another week or so to be here, but in the meantime we're going to look at this CDI unit. Zaya did some surfing around on YouTube and found a guy who pulled his CDI unit out of the outboard and then placed it in an oven and heated it up for an indeterminate period of time at an indeterminate temperature and got the thing working. So we're going to try that. It looks like the resin casing has been compromised in some way, maybe a crack, and it may be that some seawater has got into the electronics. So we've taken off, we've disconnected all of the connectors that sit inside the connector holders here. We've unscrewed the plastic connector holder, taken the two bolts off that hold the CDI unit against the side of the block, and just undoing the last two connections there to the ignition coil, and up it comes.
Here we go.
So that is the unit where we think it's compromised in some way, and the seal is on the back here, the resin that they've used to seal the back with the circuit board inside. And
here it's cut open. Here we can leak.
Yes, so it's possible that water has got in somehow into that unit.
So
pop it in the oven and see if it comes back to life.
don't you reckon we shall try to open it?
It's not openable without destroying it. If we did destroy it, we would have to reseal it, of course. I think it's filled with sand and resin, you know, it's fully encapsulated. I'm not certain about that. I've seen one pulled apart with a grinder.
Shall we take it apart?
Well, I'm not sure yet. Yeah, so we're looking for areas where it might be breached, and,
and
there's a rubber seal around where the wires enter the unit.
Here is quite a lot of space for water,
You can certainly
condense, whatever.
Yes.
And it is actually possible to squeeze it and you feel it's moving, and here
Yes.
you can just press it and it will go open like this. It is here already.
Yeah, so this looks like it was tried to be sealed, and of course it's failed over time.
Yeah.
Yeah.
So I figure it would be interesting to take the rubber away, gently just pushing it either to one side, and then
That would allow the air to get into the unit.
and us to look into it.
Yes.
Then we can see if we see anything, if there is a lot of water or moisture or whatever, possibly, and then we can decide what to do. But I like this oven technique. It sounds very funny, but yeah.
Yes, I think open
I
it
think
up.
we-
That will at least allow the oven to evaporate the water,
Exactly.
give an exit for the water.
That is really important.
But for a $400 unit, you know, it's in a water environment. I mean, it's presumably built for an outboard motor and not for one of their motorbikes. Well, they get wet anyway. It doesn't look like a very well sealed for longevity, does it? Look at that, it's coming.
Now it's open. I think it's enough. Do we see any?
And now, yeah, you can see the resin is all around the wires. There is a double sealing arrangement there. You can see it's. What you do have is one hole there,
Yep.
which would act as a vent, or possibly
Exactly.
two holes
Yes.
there.
It might be more. So how many degrees?
Well, that's all you need is a
50 degrees would be
Yeah.
excellent, and for about
half an hour. I
Yeah.
agree. That's not going to cook anything.
Because
and
if you, yes, because I mean, otherwise the sealant can collapse because of the heat. Probably won't take 300 degrees. That's quite high.
Yeah. I'm just looking at what the guy on the YouTube video used 350, which is about 170, 180 C, which to us seems a little hot. We'd rather do it at lower temperatures for longer. So we're going to turn the gas. So this is a gas oven too. It's probably not going to regulate temperature that well.
So setting it to 1.
We'll set it to 110 C, and we'll check it regularly, make sure it's not melting or falling apart. Okay, so that's the unit. We can now see the wires in there. We think we've got a vent hole to let the moisture out. Let's light up the oven. Shall I just leave it in there and let things cool down? Or bring it out?
Bring it out and show it to me. Is it baked? Is it golden brown?
I hope not. Okay, so there it is, and it's been in there for an hour now with regular checks every 10 minutes or so to make sure we're not overcooking it.
What was the temperature?
Temperature would have been, well, you could place your hand inside the air in the oven after opening it, so it wasn't so hot as to burn you, but the metal has become so hot you cannot touch it. And this plastic, you can't hold it, but you can hold it for a few seconds.
So what was the setting? You put it on?
About 1 second you can put your finger on there, but it's quite warm. The setting was 1 on the gas, which was supposedly 110 degrees C. And the gas was regulating itself. Well, the only sign of melting is the sealing resin that they use in the heat shrink. The heat shrink shrunk a little bit more and squeezed out the resin, but aside from that, the plastics, the rubber, everything else is intact. So we're now going to test it. So we're about to give it a start. Let's prime the fuel. We've just put the CDI unit without mounting it. We've just connected up all the wiring, and now we'll give it a shot.
Not a spark. No sparks going on. Okay. Easy, no problem.
So given the failure with the first test, we now have to dig deeper. Well, we don't have to because we've managed to order a part which is coming next Wednesday. Today is Thursday. However, I guess curiosity has got the best of Mick and Zaya particularly to dig deeper and try and find the problem inside the unit.
If we are lucky. But of course, it's not called Luckyfish for nothing. Let's see, yes. You see, it's quite deep.
What do you think about Mick doing this, honey? It's not like you to let a man just stay on the tools.
I'm holding myself.
Yes, you're very welcome to do it. What I'm concerned about is how deep is the gunk, as I just had in my
well, it's a
song.
How deep is your gunk?
Yes. How deep is your gunk? But I don't know what's
Why
underneath.
they fill it with this kind of stuff? What is this?
Yes, just because it should be more.
Well,
do you say?
Waterproof.
Yes, it should take more space in the engine compartment. Here we can see some electronic components that's sticking up. Yeah, and here's 3 more. And this might be a small electromagnet or just a coil of something. And here's some other stuff. So I don't want to dig deeper into this. What I want to do is to cut out deeper in the sides and hopefully be able to take the whole piece out. And we don't want to ruin anything.
You guys?
Showtime!
You guys have been amazing sticking at this. What have you done?
What we have done is that we had this circuit board was previous inside here.
Yes.
We dug out all this black stuff. See?
Yeah.
So you just patiently dug around.
Yes, it's like archaeologists. We've been digging and digging and digging and digging, and then when we couldn't dig anymore, we used acetone.
Yeah.
And we used that with where's the straw? Here. As a pipette.
Yes.
Like this.
Yes.
Sucking up, putting
Yes.
in, and then finally we have to give it up. There was a small slot on this part,
Yeah.
this side,
Yeah.
but it was not enough to get in enough. So then we decided we had to cut it open, and we made
Because
that.
the bottom was solidly
Yes,
filled with this stuff.
Yes.
yes,
Here, here's the
black
keys.
gunk. So we
Oh,
made
okay.
a slot.
Yeah.
Yeah, we cut it open, and then we could, with a screwdriver, yes, thank you, we could then put it inside, and it was all black. It was like
Oh.
3-4 millimeters of black stuff.
On the back side.
Yes.
Solidly in there.
And then poking holes and keep on,
Oh.
and then after a
Oh.
while more acetone.
Sneaky.
Some more
Very
Yes.
clever.
acetone.
Yeah,
And then
sure.
finally, after like 4 hours,
Oh,
we could pry and pry and pry, and then it went off.
Mm,
And then this was full of gunk,
yeah, that's,
and
you
you can
cleaned
see
it right
here
out.
how it looks.
Yes.
And then we had a lot of gunk here, and then we decided to clean this up and use this as a kind of a
box.
a box for it. And then we had acetone in here, and then we put this back
So with a bit.
so it
Yes.
could soak.
Oh.
And then we, with these very handy bamboo sticks, we could
Yes.
pry it off.
Yes.
Scratching,
and
scratching.
You've really got it quite clean.
Yes, and here we can see the resistors, the capacitors, the transistors, and so, and nothing is burned. Here are all the connections to the engine, which
No
correspond.
corrosion there.
No,
corrosion.
no corrosion, and nothing is burned, nothing is fried, which means that probably one of the transistor is fried, which we cannot see, or here might be an inside here. We think is an IC integrated circuit, which
Yes.
acts just like a small computer. Whatever happened, we cannot see where it was, and that was the goal of this project, to open up and see, because that is actually the first thing you do with a circuit board. You check it on the backside and see if something is fried, if something is burned, if it's like brownish, or if you can identify a meltdown in the soldering or something. But there's nothing to see. It looks fine.
Yeah.
Yeah.
So now who's up for that stuff?
Yes, maybe you are.
Yeah.
No, I'm very busy at the moment. Sorry, guys. And you're doing such a fine job.
What's your name again?
Luckyfish. This is a long story getting this part.
Documents. It should stay waterproof. And yes. So
Yeah, it looks
nice and
familiar.
shiny.
So you're happy?
I'll be happy when I hear the engine running.
So we've taken delivery of the new CDI unit, and this is how we're going to refit it. I'm going to begin with the ignition coil wires, orange and black. I'll just remove the pulsar coil. I'm going to have to check the other engine and see which way that goes on, whether it's on first or last. Can you tilt the port engine down, please? Okay, so the pulsar coil goes on first. Then the CDI unit on top of that, and then the plastic clip
connector holder goes on last. Just getting this second mount screw in is quite difficult. You have to take all the ground terminals off here in order to be able to get into this bottom screw. I don't feel like it's engaging with the thread on the other side, so try and find the mount with my finger. Okay, so it feels like this whole thing needs to be rotated up like so. Try that. Okay, we got it. These are only aluminium, so they won't require a lot of force. That's that. Now the connector holder. Can you pass me the yellow handled screwdriver out of the toolbox, please? No, just the small Phillips. Thanks. Should be a Phillips, really. Do you have the yellow handled one? That's the multi screwdriver. And we used it the other day for something. There it is there, under the yellow knife. Right hand, yeah. It's at the top. Right, don't drop the screw. Okay, real awkward one, this one. Fiddly little screw. Very difficult. See if the screw will sit there for me. Okay, feels like it's going into the old hole, just tapping into plastic, or in this case a new hole in the back of the CDI unit. Okay, that's that. That's that. Next, start connecting up the wire pairs. Yellow on the bottom, emergency troubleshooting wires. Disconnect the CDI unit when you disconnect them. Yellow to yellow. Slide those down into the lowest position on the connection strip. Next is the next shortest pair of wires, which look to be pink to pink, and there's two pairs of pink wires, so I've marked one pair with a black line so we connect them up correctly. That's one pink and
At this point we realised that the black marking for the other side of the pair was on the old unit. We would have to remove the CDI unit, match the wires up next to the old unit and start over.
the problem.
It's weird that Yamaha should use two pairs of wires that are both pink. Perhaps that meant it did not matter which was which, but we weren't willing to take the risk.
Is it how it's mounted now?
Yes. So you can, if you can just check for this one.
Are you sure? The resin is on the back of the unit or the front of the unit?
On the back.
The resin's on the side.
Yep.
So therefore it came out like this.
Yes.
You're right.
And you can identify by these ones if they are aft.
So these are the two new pink wires on the CDI unit. Obviously they don't have the black mark on them to discriminate. So we're checking the old unit to find out which one it was that was marked. And it's this one here. This is how the CDI unit would have been mounted on the engine, and that's the forward of the two pink wires. So now we're just going to check that these two aren't crossed over underneath, so we can connect them up the correct way. Okay, so we've connected up all the wires. This is the final wire, and we'll test the engine for the moment of truth. Just lower the engine. Okay, Mick, are you ready?
Yes, I'm ready. Let's go.
I'll just prime it. Here goes.
Woohoo! It's running!
That's a beauty.
We'd like to give a shout out to Dangar Stu over at Dangar Marine, and to Thinking Outside the Box, who made the vid Zaya saw and started us on the oven journey. There are links in the description. If you found this video useful and want to see more from Luckyfish, don't forget to subscribe to our channel. We'd like to give a special thank you to our patrons. It's because of patrons like you that make our productions sustainable, so please, if you haven't already, consider becoming a patron for as little as $1 a video and become part of the Luckyfish story. Feel free to question, comment, and give us a like and sub below. Until next time, thank you for watching.